kids, welcome to ICSE Chemistry Hub. Today we will be dealing with part 3 of one of the most important chapters of grade 10, that is periodic table. So today we will be dealing with ionization potential, that is IP, or we also call it as ionization energy. So without any further delay, let's dive into the topic. So as discussed before, children, we had already dealt with one of the periodic trend, and that periodic trend was atomic size, or we can also call it as, what was the other name given to it? Atomic radius. Now, if you remember, in short, what is atomic size or atomic radius? It is nothing but the distance from the center of the nucleus to the outermost shell. So whenever you have to calculate the atomic radius, we always calculate the distance between the nucleus and the outermost shell. And we had discussed how this trend varies down a group and across a period. So before we start with today's topic, I request you all to please go to the playlist and have a view about atomic radius. So today in detail, we are going to discuss about the second trend. The second atomic trend or periodic trend is nothing but ionization potential. Now, please remember here, children, whenever I use the word ionization potential, remember it in terms of energy. Okay, so possible, do not remember it as potential at all. Okay, whenever they ask you ionization potential, always keep in your mind that they are dealing with ionization energy, or it has something to do with energy. So in today's class, we will be discussing about the definition of ionization energy. We'll be discussing what is ionization energy, what are the factors that will be affecting ionization energy, and as usual, we will be discussing the trends, that is how ionization potential or ionization energy will vary across a period. That means from left to right, and how the ionization energy will vary from top to bottom, that is in a group. So let's start. Now children, what is ionization potential? I already told you. Whenever you hear the word potential, remember it in terms of energy. Okay, so let's start with the definition. Now, even in the board exam, sometimes these definitions are asked. So please listen and learn the definition very, very carefully. What is ionization potential? It is the amount of energy required. Please, this is one of the key words that you have to remember. What is ionization potential, children? It is the amount of energy that you have to provide, that you have to give. Clear? So it is the amount of energy that is required or that you have to provide. Now, why do you have to give that energy? To remove an electron from its outermost shell. Okay? So whenever I want to remove an electron, what should I put in, children? Whenever I need to remove an electron, I need to provide energy there. So ionization potential or ionization energy. So one of the keyword is the amount of energy that you have to provide, that is required. Now, why is the energy given? To remove an electron from its outermost shell. Okay. Now look at these words, children. From where do we want to remove an electron? From the outermost shell of an isolated gaseous atom. Now, why do you think this word gaseous is very, very important here? Okay. Because whenever we are talking about gaseous, we mean it is an isolated atom. That means it is not combined with anything else. Suppose if the same atom is in a solid or if it is in a liquid form. In solid and liquid form, they are always in a combined state. Okay, so they have mixed or they have combined with some other atom. But whenever they are in a gaseous form, they are in an isolated form. So whenever you hear this word gaseous atom, the word gaseous implies that it is in an isolated form. Okay, it is alone. So once again, children, what is ionization potential or ionization energy? It is nothing but the amount of energy required or the amount of energy that you have to give. Okay? It is the amount of energy that you have to provide to do what? To remove an electron from its outermost shell. But which kind of atom you will do this experiment with? You will do it with an isolated gaseous atom. And we know whenever we remove an electron, okay, what sign will the atom get? The atom will form a positive ion. Okay. So children, please remember this. I just now told you what is ionization potential, children. Whenever you talk about ionization potential, remember it in terms of ionization energy. Okay. So whenever, what is ionization potential? Whenever you have to remove an electron, you have to give it some energy. So please remember this. The smaller the atom is, for example, if I have two atoms, X and Y, one has one shell. For example, let me say A has one shell, B has three shells. So the smaller the atom is, more energy I have to provide to remove an electron from its outermost shell. And more the number of shells, I have to provide it with less energy to remove an electron from its outermost shell. Okay, so smaller the atom, the harder it is, the more difficult it is to remove an electron. When I say it is difficult, that means you have to provide it with more amount of energy. Okay, so these are the very, very small things that they sometimes ask for a 1-marker question, which you will exclusively get only here. So please do, without any fail, please do like, subscribe and share our channel. Also do put your valuable comments here. So children, as I told you, if I say that the ionization energy is high, I mean I have to put in more energy to remove an electron. Okay, so if I say that the ionization energy is high, ionization potential is high, what did I ask you to remember? Potential means energy. If I say high ionization energy, that means I have to provide more amount of energy. That means it is going to be really difficult to remove an electron. And suppose if I say it has got low ionization potential. Whenever I say potential, it means nothing but low ionization energy. That means with less amount of energy, I will be able to remove an electron. Okay. So which amongst this, okay, you have francium and you have helium. Which amongst this will have a low ionization potential? Can you just look at the diagram and answer me? I just now told you, more the number of shells, okay, more easier it is to remove an electron, okay. More easily an electron can be removed. So if more easily it can be removed, less will be the ionization energy. The more farther away the electron is from the nucleus, more easier it is for me to remove an electron. So more easily I can remove the electron. That means I have to provide it with very, very less energy or very, very less ionization energy. Whereas can you see here for helium, children? It is the electron that I want to remove is very, very close to the nucleus. Nucleus is positively charged. My electron is negatively charged. They are very much attracted to each other. So here, it is going to be very, very difficult for me to remove the electron. So when it is difficult, I have to put in more ionization energy. Is this clear? So which has got more shells? They will have less ionization energy. Do you remember the sentence? The more smaller the atom, more difficult will it be to remove an electron. More will be the ionization energy. More larger the atom, more easily I can remove an electron, so less will be the ionization energy. Okay, so now let's delve into the factors that are affecting ionization potential. Now, as I told you, don't remember this as potential. Remember it as energy. So, what is the first factor, children? The first factor affecting ionization energy is atomic size. I just now showed you a diagram. The more larger the atom, okay? Can you see here, children? The more bigger the atom, less energy is required to remove an electron. So when I say less energy, I mean less ionization energy. So can you see here, children? As the atomic size increases, what will happen to the ionization energy? More larger the atom, less will be the energy that I have to provide. Okay, so lesser the energy, that means ionization energy decreases. Yes or no, children? So as the atomic size increases, the ionization, that is why I have asked you to remember it in terms of energy. More larger the atom, more farther away it is from the nucleus. So what will happen to the ionization potential or the ionization energy? It decreases. Now just go through the slide once, children. Because the atomic size is increasing, can you see here? The atomic size is increasing. Here is the nucleus. This electron has become very, very far away from the electron. This is clear. So, as the atomic size is increasing, the ionization potential, the nucleus is becoming farther away from the outermost electrons. So, what happens to the attraction, children? The attraction becomes less. The lesser the force of attraction, more easily I can remove the electron. Okay, so more easily the electron will be removed, less will be the energy. Clear? So the first factor that is affecting ionization potential is atomic size. As the atomic size increases, more the distance from the nucleus to the outermost shell, the ionization energy also will decrease. Okay, with less energy, I will be able to remove an electron. The second factor that is affecting ionization potential is nuclear charge. In my previous class only I had told you, more the power of the nucleus. Now what is going to give me the nuclear charge? Nuclear charge is nothing but the atomic number. Okay, so nuclear charge is nothing but how powerful the nucleus is. As the nucleus becomes more and more powerful, more will be the pull. Okay, so as you can see here, children, as the nuclear charge increases or as the atomic number increases, the nucleus is becoming more and more powerful. More powerful the nucleus, more will be the force of attraction. Okay, more powerful will be the nucleus. Okay, so what is going to happen, children? The outer electrons will be very, very difficult for me to remove it. Am I clear? So can you see here? The nucleus is becoming very, very powerful here. Okay, so it is becoming more difficult for me to remove an electron. Okay, and more difficult it is, how much energy should I put here? I should put in more energy to remove an electron. So as the nucleus becomes powerful, okay, more strongly it will hold the electron. It will not allow me to remove the electron easily. So how much ionization energy do I have to put? I have to put in more amount of energy. So I hope the two factors affecting ionization potential are clear to you. Remember it in terms of ionization energy. So let's start now with one of the last thing, that is we will discuss the trend from left to right. So we will first start with how ionization potential differs across a period. What is the meaning of the word across a period? From left to right. So we know what are the two factors that will affect ionization potential. The first one is atomic size. Okay. So we have lithium. We have taken the second period here, children. So we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Before only we know that ionization potential is dependent on two factors. Ionization energy, that means how much energy I have to give, is dependent on two factors. Which are the two factors, children? The first one is atomic size and the second one is nuclear charge. In our previous class, we had already discussed the atomic radius trend. From left to right, atomic size is decreasing. We have learned this. If you have any doubt here, please go back to the playlist. Have a look at the atomic radius first, because only if you understand this trend will you understand what ionization potential trend actually is. So this we have already discussed. You should remember this, that atomic size from left to right, that means across a period, from left to right it is going to decrease, and from top to bottom it is going to increase. Clear? So please keep this in your mind when you are starting with ionization energy. Left to right it decreases and top to bottom it increases. Now let's look into it. Okay, so the two factors is, first one is atomic size. We know from left to right the atomic size decreases. Okay, so what is happening to the atomic size, children? As you can clearly see in this diagram, when I am moving from left to right, the size is slowly decreasing, and we have learned this. More smaller the atom, see, if you can have a look at the diagram here itself, here the nucleus is far, here it is a little near, little more near, but as I am coming to fluorine, can you see the nucleus is very much near to the outermost shell. So as the atomic size is decreasing, that means more nearer it is, the electron is to the nucleus. So I have to provide more energy to remove an electron. So if more is the energy that I have to apply, more will be the ionization potential. So as you know, from left to right, the atomic size is decreasing. So as it decreases, it is more closer to the nucleus. And so I have to apply more energy to remove an electron. More is the energy, more is the ionization energy, or we can call it as more is the ionization potential. Am I clear? So as the atomic size is decreasing, I have to provide more amount of energy. Clear? Now what is the second factor, children? The second factor is nuclear charge. Who will give me the nuclear charge? The atomic number will give me the nuclear charge. So what is the atomic number of lithium? Lithium has an atomic number of 3, beryllium has 4, boron has 5, carbon has 6, 7, 8 and 9. Clear? As I am moving from left to right, the nuclear charge is increasing, or can I say the nucleus is becoming more and more powerful. Okay, more powerful the nucleus, more difficult it is going to be to remove an electron. Yes or no? So more difficult it is, I have to put in more amount of energy. More the energy, more will be the ionization potential. So I hope these two trends are clear to you. So here also ionization potential is increasing. Here also ionization potential is increasing. So what can I say here? That the ionization potential from left to right increases. Yes or no, children? Okay. Now let's start with how the ionization energy will vary down a group. When I say down the group, I mean from top to bottom. We know that top to bottom, the atomic size is going to increase. When I go from top to bottom, the atomic size will increase. More larger the atom, it's going to be very, very easy for me to remove an electron. So less energy I have to apply, yes or no? Less the energy, ionization potential will be less. Clear? So as the size increases, the amount of energy required also decreases. So less amount of energy, I will be able to remove an electron. So the ionization potential decreases. The second factor affecting is nuclear charge. Okay. Now if you have a look at the atoms, hydrogen has an atomic number of 1, lithium has an atomic number of 3, sodium has 11, potassium has 19. So what is happening to the nuclear charge here, children? The nuclear charge is increasing. And as the nuclear charge increases, what is the meaning of the word nuclear charge increases? More powerful the nucleus. More powerful the nucleus, more difficult it will be for me to remove the electron. So more difficult means I have to provide more energy. Okay, so at one place ionization potential is decreasing, at one place ionization potential is increasing. Now here comes the question, which one will dominate? Always remember, nuclear charge never dominates. Okay, this is given the least priority. So look at the sentence written here. Increase in atomic radii dominates over increase in nuclear charge. Always remember, wherever there is nuclear charge, you have to ignore that as a factor. Why you are ignoring that as a factor, children? Because at one place it is decreasing and one place it is increasing. So here you will have a confusion about which one to take. So please remember, atomic radii or whichever is the other factor is always going to dominate. We have hence concluded that down a group, ionization potential will decrease. Clear, children? This is the trend that you have to remember for ionization energy or ionization potential. I would prefer that you do not remember the word potential here. Whenever you hear the word ionization, remember it, you have to give energy to remove an electron. Clear? So please remember this trend. It is the exact opposite of atomic size. Atomic size from left to right was decreasing, top to bottom it was increasing. Left to right, ionization energy increases and top to bottom ionization energy decreases. Clear? Now one last question that is mostly asked in the periodic table. So they will ask you that which element in the whole periodic table has the highest ionization energy. Now you know, children, what is ionization energy? It is the amount of energy required to remove an electron. Okay, where do you think I will have to apply maximum energy? I have to put in a lot of energy to remove an electron. It will be this noble gas. Which is that noble gas, children? It will be helium, one of the commonly asked board question. An element in the periodic table with the highest ionization potential is helium. And we know ionization energy from left to right increases. So this is already a duplet. It is stable. But if I have to remove an electron, this helium is going to be the most difficult element. I will have to put in a lot of energy to remove an electron. Whereas the element with the least ionization energy will be francium. Okay, francium is a very, very big atom. So with very, very less amount of energy. Okay, it's a very, very big atom with a large number of shells. So with a very, very less amount of energy, I can remove an electron. So for francium, the ionization energy is the least. So maximum energy has to be given for helium and the least energy has to be for francium. I hope this trend is clear to you. Okay. So children, please, if you have liked this video, if you have understood this topic, please do like, share and do subscribe the channel. And also do stay tuned for another important concept, that is electron affinity, which will be put up for you very soon. So please stay tuned, keep revising, keep learning, and please do subscribe without fail.